Okay, so I'm just doing a brief tour here of this clock generator board using the, see here, the Si5361 IC. So let's start off. So we have here a LCD for frequency readout, and there's two different frequencies shown. So there's the main frequency of the receiver, and then this is the BFO frequency here. So they, in essence, what happens is there's three clock outputs. Only two are used as on a standard receiver. So clock 1 is the BFO frequency, so this would be 4.914200 megahertz, and clock 1 should be the sum of these two frequencies, or the difference. But in this case, I'm using it as the sum. So it should be 7 and 4, 11, nearly 12 megahertz. So that would give you then your, for the superhet, which I'll briefly go through here. But so there's a rotary encoder. So as you do this, you see the frequency change. These two switches are just set up for, one is to increase the tuning rate. That's 100 hertz, 500 hertz, 1 kilohertz, 2.5 kilohertz, 10, 100, 1 meg. And this one is to reduce it. So the lowest I've set up for the moment is 50, and the highest is 1 meg. This is to change the BFO frequency. So if you press that, see the BFO frequency change. And the final one, let me turn up this guy here. You'll see there's a, hard to see there, there's a perfectly matched antenna here. So when I press this, okay, that's basically outputting the frequency perfect for a Morse code transmitter. That's been picked up by the receiver here on the right, and you can hear. So a nice way of aligning your receiver. The output from the receiver. Let's see, I have it on a different one. Let me just pull this up here. See what that. And need to change our. So we'll do 5 volts there. Try that then. And so that's the audio output from the you can see it's pretty nice symmetrical sine wave. And we adjust our IF gain, you can see it goes nice and down. So what we're adjusting there is this guy here. So that's the operation of it. The technical side, so we've put 12 volts on the input as a 2 linear regulators. That's a 5 volts, that's a 3.3 volts. I think I have a blank board here which might be easier to explain some stuff on. So the 5 volt is for the LCD, and there's a pot there, see here, for adjusting the LCD contrast. It uses a ARM microcontroller, and it's from ST. It has all the flash and SRAM and lots of peripherals all built in, so quite straightforward to hook up. Then you'll see here the connections go up to the to communicate with the LCD from the ARM, and you can program the ARM from this header here. There's a UART on it, so serial port, lots of GPIO for various different any type of functionality that you'd like yourself. And then there's I2C going over here to the main clock generator chip. Very, very small little guy. And these are the pull-up resistors for the I2C out to the 3 clocks. So it's quite complex programming, this guy, but there are libraries available. So I just adapted one of those for the STM32. Yeah, so then you got your switches, rotary encoder here. That's pretty much it on the board. 25 megahertz crystal goes there. So this is the final unit, and so all the software will be available or is available depending on when you're watching this. I'll put a link in the video forward. So if anyone wants to make modifications, it'll be open sourced. Anyone wants to make modifications, they're more than welcome. That's all for now, folks.